Hello friends, in today's session we are going to complete all the remaining topics for multi-threaded programming. Okay, so we were seeing about the wait statement, wait function, notify and notify all. Some points are the left regarding these functions, so we will see them. Additional forms of wait exist that allow you to specify a period of time to wait. Before working through an example that illustrates inter-thread communication, some important points are there. Notify, notify all. Although wait normally waits until notify or notify all is called, there is a possibility in very rare cases that the waiting thread could be awakened due to spurious wake up. There is some emergency in some cases, means those cases are very much rare, but this can happen that wait does not sleep. If the emergency appears, the wait awakens in that particular time. In this case, a waiting thread resumes without notify or notify all having been called. Means it does not message them or notify them, and before they are called, it is awakened before them. The thread resumes for no apparent reason. Because of this remote possibility, Sun recommends that calls to wait should take place within a loop that checks the condition on which thread is waiting. That is, wait should take place within a loop, any loop that you can use that checks the condition on which thread the thread is waiting. So periodically, Sun recommends that periodically wait should be rechecked that it is sleeping or not. And if it is halted in between for some emergency reason, it should take care of that particular problem. The following example will show this. Now we will see the example of wait and notify. Consider the following sample program that inherently implements a simple form of producer and consumer problem. Now there are four classes. Queue is the queue that you are trying to synchronize. Producer, the threaded object that is producing queue entries. Consumer, the threaded object that is consuming queue entries. And the PC, the tiny class that creates a single queue, producer and consumer. Okay, so PC is a different class that creates a single queue that you are trying to synchronize, one producer that is threaded object and one consumer. Incorrect implementation of producer and consumer. Class queue. Now synchronize integer get system.out.println. We are in get. What we are doing, this is a synchronize function, and whatever value we are got, we are returning into integer format. Now second method is also synchronized, that is put method. One is writing to it and other is reading to it. Then this dot n is equal to n. This is the parameter we have passed as integer, and this will be initialized. This local variable n, this integer n will be initialized to this particular n, and we are printing put n. Class producer implements runnable. So producer will implement the runnable interface. Okay. So where there is one queue created, producer queue passed, this dot queue is initialized to queue, new thread this producer dot start. Okay, so this is initialized, this is instantiated thread object, and it is directly started without creating like thread t is equal to new thread this producer. It has been directly called like new thread this producer dot start, and queue initialized to this value that we are passing to the parameterized constructor. Whatever object we will be creating our queue, it will be passed to the producer. Now in run method, unless and until true is there, what we are doing in queue, we are putting I dot I plus plus. Okay, so I plus plus will be put into queue. So this is our queue. Now consumer also implements runnable. It has also passed the queue parameter queue object. This dot queue is initialized to this object, and new thread is here also created, that is consumer object, and run while true queue dot get. So simultaneously this true will also execute and this true will also execute. Now PC is a different class that creates one queue object, one producer object, and one consumer object. So first of all, it will create one queue object. Then it will create one producer object and it will create new consumer object. Now it will go into infinite loop. For that purpose, it has been printed that press Ctrl C to stop. The put and get methods are synchronized. Nothing stops the producer from overrunning the consumer, nor will anything stop the consumer from consuming the same queue value twice. Okay. So queue object is a single object that we have created. Okay. In the queue object, what we are doing, we are getting the value and we are also putting the value. So same queue object is passed to the producer to produce the value and it will put into the queue, and second is whatever the consumer is, it will get value from the queue. Okay, so same value will be operated upon. Like we are entering here, we are putting suppose 0 1 1 2 and 3. At the same time, the same value can be get over here 3 2 and 1, like this. Okay, so it is not expected result that we are going to produce, and those are synchronized, but one same object of queue we are passing. For that purpose, nothing will stop the consumer from consuming the same queue value twice. Thus you get the erroneous output shown here. The exact output will vary with processor speed and task load. Okay, so depending upon your processor speed and task, output will be different. One is putting, second is getting, other is getting and getting. This is not expected output. Still they are since they are synchronized, we expect them to be producing output first, putting value first, and then consuming value next, but this is not the expected result. Now got 1, again put 2, put 3, put 4, put 5, put 6, put 7, then got 7. Okay, so latest value is 7, that will be got. So this is not the expected output. After the producer put 1, the consumer started and got the same one 5 times in a row. Okay, then the producer resume and produce 2 to 3, 7 without letting the consumer have a chance to consume them, even if both are synchronized methods. So this is not expected at all. The proper way to write this program is you to use wait and notify to signal in both directions as shown here. So we will modify this program now. The correct implementation is here. How we will achieve this? Using value set variable, that is boolean variable is equal to false. Synchronize integer get while, not value set wait. Okay, value set is not equal to true. This line means that unless and until value set is not equal to true, it has to wait, and then it is catching the interrupted exception E. Now after that, it is got value set is false, notify and return this value. Now put while value set is true, try, in that we are waiting, and if it is interrupted in between, interrupted exception is got. After that, we are putting the value and value set is equal to true, and then notify. Now producer will implement the runnable. Okay, so this dot q will be initialized to q object, same object we are passing both to producer and consumer, and in run what we are doing, q dot put I plus plus as in the previous example. Okay, so both producer and consumer classes are same as the previous example. Here this dot q is equal to q and consumer is started over here. Now run while true q dot get. Now this is the main class we are having. Same object is created and passed to both of the classes. Then press Ctrl C to stop. Now inside get wait is called. This causes the execution suspend unless producer notifies you that some data is ready. Unless and until data is put into the queue, you cannot get from the queue. When this happens, execution inside the get resumes. So this is the very much good advantage of your wait and notify function. After the data has been obtained, get calls notify. Okay, So notify will notify the put to put the value. This tells the producer that it is okay to put more data in the queue. Inside put, wait suspends until the consumer has removed item from the queue. Okay. So whether when one is producing the data, other cannot consume it unless and until data is produced, and when consumer is consuming data, the producer cannot produce the next data. So this is the sum output of this program, which shows the clean synchronous behavior as we have expected. Okay, so using only synchronized keyword, it is not the only solution. In some cases like this, output is not expected. In the previous example, it was not as expected as it was in the previous example. And here it is the clean synchronous output. One is putted, one then got one, put two, got two. This is the way, this is the output that we was expecting from the program. Now we will see the deadlock. A special type of error that you need to avoid that relates specifically to multitasking is a deadlock, which occurs when two threads have circular dependency on a pair of synchronized objects. Okay, so special type of error is called as deadlock, and that relates specifically to multitasking, and it will occur when two threads have circular dependency on pair of synchronized objects. Okay, dependency is circular, still it is a synchronized object. For example, suppose one thread enters the monitor on object y x and another thread enters on monitor on object y. If a thread in x tries to call any synchronized method on y, it will block as expected. Okay, so one thread, there are two threads and there are two monitors. One thread enters the monitor on object x and another thread enters the monitor on object y. And if x tries to call any synchronized method that is in y, it will block as expected. If the thread in y in turn tries to call any synchronized method on x, the thread waits forever because x is waiting for y and y is waiting for x synchronized method to call. Because to access x, it would have to release its own lock on y. Okay, so that first thread could complete. What is this? This means that x is waiting for the synchronized method on y. At the same time, y is also waiting for the synchronized method in the x. But to access the x synchronized method, it has to release first its own lock, so that x will complete and then x will come out of its lock or monitor, and y can have the access it. But at the same time, both are waiting for the synchronized methods of each other, and y will never complete in this case. Okay, so first thread and next thread, that is x and y's thread, will never complete. Deadlock is a difficult error to debug. Why? In general, it occurs only rarely. Okay, it does not occur when two threads time slice in a just right way. Okay, both threads are acquiring the lock on two different objects and they are trying to call synchronized method of each other, and this case is very much rare. It may involve more than two threads and two synchronized objects. Okay, when there are only two threads and two synchronized objects, it is still okay to debug, but it is not the case all the time. It may have more than two threads and two synchronized objects. Deadlock can occur through a more convoluted sequence of events than just described. So we will see the example. A and B with methods foo and bar respectively, which pause briefly before trying to call a method in other class. The main class named deadlock creates an A and B instance and then starts a second thread to set up the deadlock condition. Okay, the main class is what? Deadlock. There are two classes, A class and B class. A is having foo class, then B is having A is having foo method and B is having bar method, and both possess briefly before trying to call method in other class. And the main class deadlock creates an A and B instance and then starts a second thread to set the deadlock condition. Foo and bar methods use sleep as a way to force the deadlock condition to occur. Now we will see synchronized void foo. You can see the method is synchronized, still deadlock can occur. Void foo, and it has been passed the object B. String name is equal to thread.currentThread.getName, that is main thread's name. Name entered A. Now thread is sleeping for 1 second and interrupted exception. Then name trying to be called B dot last. Then synchronize void last inside A dot last. Okay. Then class B, synchronize void bar A. Here we are passing the object of A. In class A, we are passing B's object to foo method, and here we are passing the A object to bar method. Here also we are getting the current thread name, that is main thread name, and name is entering B dot bar. Now again it will sleep, and after awaken from the sleep, if it is not interrupted in between, name trying to call A dot last. Okay. So synchronize void foo is a synchronized method, and synchronize void last, it is also synchronized method. Then bar is also synchronized method, and last is also this is called from B, it is also synchronized method. Now synchronize void last inside A dot last. Now we will see how deadlock is occurring. A is equal to new A. Two objects of A and B are created. Then current thread name is main thread, and thread is equal to racing thread. Racing condition or deadlock condition is occurring, so that we have given the name as racing thread and T dot start. A dot foo B get lock on A in this thread. Now A is the object of class A, and this is the default constructor of deadlock class. What we are doing here, we are getting the current thread and putting a name as main thread to that thread. After that, we are creating a second thread, that is racing thread. After that, A dot foo, we are calling A dot foo. So foo method is over here. This class A is foo method. Okay, and to that what we are passing B's object, get lock on A in this thread, back in main thread. Now in run, B dot bar A. So B is passing the object of A, get lock on B in other thread, back in other thread. Now new deadlock is directly called. Okay, so after this call is done, what will happen? This will come to the default constructor. After that, it will get locked on this thread A dot foo, and B is passed over here. And after start, this is started first. After start, B will acquire the lock on A, get lock on B in other thread. And after this is done, it is returning over here, and A dot foo B get lock on A in this thread. So what is the output of this program? Main thread entered A dot foo, racing thread entered B dot bar, main thread trying to call B dot last, racing thread trying to call A dot last. Last method is synchronized in both the classes, but still they has to relinquish control on its own lock. After that only it can the second thread can access to its method, and then it will finish, and this same class will access the methods of the other thread. So this is the deadlock condition. Because the program has deadlock, you need to press Ctrl C to end the program. You can see a full thread and monitor cache dump by pressing Ctrl break on a PC. If you want to see the complete detail, you can press the Ctrl break on PC. And you will see the racing thread owns a monitor on B while it is waiting for the monitor on A. Okay. it is owning its own monitor, and still it is waiting for the monitor on A. So what it has to do to remove this deadlock condition? It has to relinquish control its own monitor on B, so that A can acquire its monitor, and then after A is finished its working, the racing thread can acquire the A's monitor. At the same time, main thread owns A and is waiting to get B. So both have its own lock. They don't want to relinquish control on its own lock or own monitor, and they are trying to access each other's methods. Those are synchronized. This program will never complete, and for that purpose, we have to enter Control C. If your multi-threaded program locks up occasionally, deadlock is one of the first conditions that you should check for. Okay. If you are multi-threading in your Java application and there is nothing happening in your program and it is locked up, so what is the first condition you should check? That condition is deadlock condition. Suspending, resuming, and stopping thread. Sometimes suspending is useful. Suspending execution of thread is useful. For example, a separate thread can be used to display the time of day. And if a user does not want it, it can remove. It can be suspended. Suspending thread is a simple manner, and restarting is also a simple matter. Mechanisms to suspend, stop, and resume threads differ between early versions of Java, such as Java 1.0, and modern versions beginning with Java 2. Okay. To suspend, stop, and resume threads differ. Early versions of Java, like 1.0, and after Java 2, how we will suspend and stop and resume the threads, these are different. And although you should use the modern approach for all the code, you still need to understand how these operations were accomplished for earlier Java environments. Why? Because update or maintain older legacy codes. Okay. So nowadays we do not use Java 1.0 first of all, and we are using the modern approach to handle multi-threading and to handle suspend, stop, and receiving the thread. But still, you need to know how they were suspended, stopped, and resumed in Java 1.0. Why it is important? Because you may have the legacy code, older code, and in your job or in your whatever business you are doing, you may have the legacy code that is older and it is written in Java 1.0. So in Java 1.0, whoever have written that code, he or she maybe use the suspending, stopping, and resuming functions in Java 1.0. So if you are already known about these methods, how they are written, so it will be easy for you to modify this code if it is needed. And you also need to understand why change was made. And one more thing, you have to understand why that change was made. Now we will see both the ways. Original way, that execution of thread was controlled, followed by a section that describes the modern approach. Now we will see both the approaches. Suspending, resuming, and stopping threads using Java 1.1 and earlier. Okay. Now, before Java 2, program used suspend and resume methods, which are methods defined by thread class, to pause and restart the execution of thread respectively. Okay. So for pausing, suspend was there. For resuming or restarting, resume function was there. Final void suspend and final void resume. The following program demonstrates these methods. Class new thread implements the neighbor, then string name thread T created, instantiated over here. Name is equal to thread name that we are passing to this parameterized constructor. Then T is equal to new thread, this dot, this and name. This name is passed. Then started thread. Entry point for thread run method. I is equal to 15, I greater than 0, I minus minus 15 times this will be happening. 200 milliseconds this will sleep. Okay, so it is less than 1 second to 2 millisecond it will be there. Okay, then catch interrupted exception E. Exception is caught over here, and what we are doing, two threads are created, 1 and 2. Okay, thread dot sleep and 1000, that is 1 second. Object 1 dot t dot suspend. Object 1 thread is suspended and suspending thread 1. Again thread is sleeping for 1000 millisecond, that is 1 second, and same is resume. Resuming thread 1 for object 2, then suspending thread 2, and again resuming. Okay, so suspending thread 1, resuming thread 1, suspending thread 2, resuming thread 2, with a pause of 1 second in each of the operation, and interrupted exception is also called. Here join is called, waiting for all the threads to finish, and main thread interruption. Now sample output is new thread 1, 2, 1 is 15. Okay, so two threads are created. This output is different depending upon your processor speed and task load. So 2, 15, 14, 14, 13, 13 and 12. Okay, so one is doing what? Suspending thread 1, resuming thread 1, and suspending thread 2, resuming thread 2. Okay, both the threads are started here in the new thread class t dot start. Now 2 is 12, 1 is 11, 2 is 11. Suspending thread 1 after 1 millisecond. 1 second. So after this much operation is done, from 15, 14, 13, 12 and 11, thread 1 is suspended. After that only 2 is running, 10, 9, 8, 7 and 6 is printed, resuming thread 1. Okay, so now 1 will run and 2 will be suspended. Then 1 only run, 10, 9, 8, 7, 6. Then resuming thread 2. Okay, waiting for threads to finish. So all the remaining operations will be done. After that 1 suspend and 1 resume. After 1 suspend and resume, all the remaining operations will be done. 5, 4, 3, 2, 1. 2 exiting, 1 exiting, main thread is exiting. Okay, so main thread will be exited last, as we have already seen. Thread class also defines a method called stop that stops the thread. This is the stop, and this is very important line you have to remember. Once a thread has been stopped, it cannot be restarted using resume. There is a difference between suspend and stop. If you are suspended a thread, it can be resumed, but if you are stopping the thread, it cannot be resumed. Modern way of suspending, resuming and stopping threads. While the suspend, resume and stop defined by the thread seem to be perfectly reasonable and convenient approach to manage the execution of threads, they must not be used for new Java programs. Why? The suspend method of thread class was deprecated by Java to several years ago. Okay, so nowadays we may be operating upon the newer Java versions, and this was done because suspend can sometimes cause serious system failures. Why? We will see that. Assume that a thread has obtained locks on a critical data structures. If that thread is suspended at that point, those locks are not relinquished. Okay, so suppose thread has obtained lock on critical data structure, and if that thread is suspended in between, those locks cannot be resumed. The other threads may be waiting for those resources can be deadlocked. Okay, so main thread that is having that critical data structure, if it is told to suspend in between by a programmer, and other threads waiting for that critical data structure may be deadlocked. Now, the resume method is also deprecated. It does not cause problem but cannot be used without suspend method as its counterpart. Okay, if you are not using the suspend, you cannot use the resume method. The stop method of thread class 2 was deprecated by Java 2. This was done because this method can sometimes cause serious system failures. Thread is writing a very critical, important data structure and it's completed only part of its changes. And if it is stopped in between, the data structure might be left in a corrupted state. Okay, so suspend is also deprecated, stop is also deprecated, and resume cannot be used without suspend. So for the cases like writing to critical data structures, it can be a reason to, it is the reason for that it is not used in a newer Java versions, because you can't now suspend, resume or stop methods to control a thread. You might thinking that no way exists to pause, restart or terminate a thread. Okay, so you may be thinking that there is no option available, but it is not true. Fortunately, this is not true. Instead, a thread must be designed so that run method periodically checks to determine whether that thread should suspend, resume or stop its own execution. Typically, this is accomplished by establishing a flag variable that indicates the execution thread state of the thread. Okay, so what we will do in this case for newer Java versions, we will design a thread in a such way that run method will periodically check to determine whether that thread should suspend, resume or stop its own execution. Okay, so thread will itself check for the need to suspend, resume or stop its own execution. And how it will be achieved? Using a integer flag variable. As long as this flag is set to running, the run method must continue to let the thread execute. Okay. So what we are doing, we are establishing a flag variable, and as long as this flag is set to running, the run method must continue to let the thread execute. If it is running, run method continue. If it is suspend, thread must pause. If it is stop, then thread must terminate. And of course, varieties of ways exist in which to write such code, but the central theme will be same. So you don't need to worry about it. If you have understood the basic way to write it down, it will be easy for you for all such type of program. The following example we will see that will explain you how the wait and notify methods that are inherited from objects can be used to control the execution of thread. And this example is similar to the program in the previous section, but deprecated methods suspend, resume and stop are removed from this program. Let us consider the operation. The new thread class contains a Boolean instance variable named suspend flag, which is used to control the execution of thread. It is initialized to false by the constructor by default. Then the run method contains a synchronized statement block that checks the suspend flag periodically. If that variable is true, that is suspend flag is true, wait method is invoked to suspend the execution of thread. Okay, and the mySuspend method sets the suspend flag to true. So when this suspend flag is true, wait method is automatically called to suspend. Automatically means by us it is called to suspend the execution of the thread, and the task of making this suspend flag true is done by mySuspend method. The myResume method sets the suspend flag to false and invokes the notify to wake up the thread. Okay, so myResume, suspend flag false and notify will wake up the thread. Finally, the main method has been modified to invoke the mySuspend and myResume methods. So there is one slight change that we should understand. Now, new thread implements runnable. This is the class. Then string name, name of the thread, thread T, suspend flag. This flag we have added in this program. Then suspend flag is initialized to false in this constructor and started the thread. This is the entry point for thread public void run. For 15 times as the previous example it will run. Okay. Then synchronize block. This is very important thing we have to understand. It's synchronize block. While suspend flag, it has to wait. Okay. Then interrupt exception, thread exiting. Then my suspend will do suspend flag to true. And if it is true, wait should call the thread to wait. Okay. And resume suspend for flag to false and notify will tell the thread to awake. Okay. Wait will tell the thread to go and sleep. They as simple as that. Wait will tell what? If suspend is true, means what? Wait will tell the thread that go, you are suspended, now you can go and sleep. And after suspend flag is false, my resume will call the notify method. Notify will tell that thread that you can awake now and you can come to your work now. So it is as simple as that to understand it. Now, we have created two threads, 1 and 2. Thread dot sleep 1000 seconds. Object 1, my suspending thread 1, again 1 second. Object 1 dot my resume, resuming thread 1. Then object 2 dot my suspend, then suspending thread 2, and object after 1 second, object 2 dot my resume, resuming thread 2. Interrupted exception is also called. Now waiting for the threads to finish, object 1 dot t dot join, object 2 dot t dot join. Output of the program is identical to that shown in the previous session. Now, we will see more examples in upcoming sessions that use a modern mechanism of thread control. Although this mechanism is clean as the old way, nevertheless, it is the way required to ensure that runtime errors does not occur. To handle our critical data structures like files, linked lists, and so on, we cannot use those suspend, stop, and resume methods. Okay. It is not the best way to use the suspend flag. It is not a convenient way as the methods was there. But still, for saving our system failure, for saving our system from failures, we have to use these methods. Use this method to write the program. It is the approach that must be used for all new code, and we have no other option. Now, using multithreading. The key to utilizing Java's multithreading features effectively is to think concurrently rather than serially. Okay. So if you want to write a program for multithreading, so you have to just change your thinking pattern. You can think to doing multiple tasks concurrently rather than serially, one after another. One after another will do what? CPU cycles will be wasted. And if it is done concurrently with the round robin fashion is equal time slice, then your time will be saved and your CPU waiting time will be eliminated. When you have two subsystems within a program that can execute concurrently, make them individual threads. Okay. There are two subsystems in your program that can execute concurrently. So two functions, if in your program there are two functions that can be called simultaneously or concurrently, you can create two separate threads for two different methods. With the careful use of multithreading, you can create very efficient programs. A word of caution is in order, however, if you create too many threads, you can actually degrade the performance of your program rather than enhance it. So it is very important line, you should understand it. If there are multiple threads, many more threads, you are actually downgrading your performance because context switching from one thread to another thread. Okay, so if there are 2 seconds allotted to each and every thread. So context switch from one thread to another thread, one thread to another thread, one thread to another thread. It will consume your time. and it will downgrade your overall performance. So keep the threads as minimum as possible. If you create too many threads, uh, were some overhead is associated, like related to time with context switching and also efforts of CPU. If you create too many threads, more CPU time will be spent changing context than your execution of your program. Okay, so this way we have completed all the theory part of multithreading. This is the reference I have used for creating the PPT slides from the book, the complete reference of Herbal Shield, and I attribute all the icons that I have used in my PPT. Those icons are taken from Flat Icon website, and these icons are very much attractive and very much convenient to use for my slides and for every other slides. I really appreciate their efforts for creation of icons. I attribute this. Please make a note of these icons. I'm really thankful to all of them. You can go to this slide. You can write down this link and you can go to the Flat Icon website. Thank you for watching the video. We will meet in the next session to complete the practical part of multithreading. Thank you so much.